Alright, today I'll talk about the problem Snail Trails. So in this problem, we're given this grid and we have to find the longest path that we can travel. And here what we can do is use basic DFS. So we can brute force all of the possible positions. So here's the code. First I'll read in the inputs and convert those two into rows and columns. And here I will use this 2D array to keep track of the stuff. So if there's an obstacle, then we'll just set this to 1, and if it's an empty space, we'll set it to 0. Also, if we've already visited that grid, we'll set it to 2. So here we will have two possible starting positions. The first one is when we go, the first possible position is when we just go right. The second possible starting position is when we start going down. And so we'll use this recursion. This D will keep track of which direction we're currently facing, and F will come into use when we do some turns. So every time we visit this, we will set this G to 2, meaning that we visited this, we already visited this column and row number. And here we will check what we should do in the next move. The first possible case, there are a few possible cases. The first few ones will be when the move is still within the boundary. So if it's outside the boundary, you have to turn. And if you're still within the boundaries of this grid, then there are a few possible ways you can move. The first way is when the thing in front of us, when the space in front of us is empty. That means we can visit that spot. And we will just use DFS again, but this time set it to the spot that we're going to, and increase it by 1 because we should count this current grid as a position as well. And otherwise, there's another position. Possible way will be if the block in front of us is an obstacle. If it's an obstacle, then we will check if we haven't turned yet. So this will prevent us from turning twice in a row, because you're only allowed to turn once and move somewhere. Because if you turn twice, you have to visit your grid again. So here, if we're just moving straight forward, we won't have to turn, so we'll just set this to 0. And otherwise, if we need to turn, we'll make sure that we didn't turn yet, and then we can find the two possible ways of going. The first possible way is when we increase this by 1, or increase the direction by 1 and modulate this by 4. The other way is when we increase it by 3 and modulate 4. So I'll use this array here to keep track of that. And why this works is because, for example, let's say you're at this direction, meaning that you're going down. You're currently going down. So the first way is when you turn. So you can turn to moving left, which is this possible one. And if you add it by 3 and modulate 4, so this added by 3 will become 4, modulate by 4, it will become 0, and 0 is this one. So this means that we're going to the right now. So this is why I ordered these moves in this position. And also we'll have to set this to 1, meaning that we just made a turn. The other case is when we are at the border of this grid. So if we're at the border of this grid, we also have to make sure that we haven't turned yet. So if we didn't turn yet, then we will turn and also choose the maximum between these two possible turns. So one is turning to the left and one is turning to the right. Finally, we can set this to not visited again. Set it to 0, meaning that there's an empty space again, which is available for us to go to, and return the result. Here, if we've already if we encounter a grid that we've already visited, then this will not do anything, and the result will just remain as 1, meaning that the only possible grid, the total grid count is only 1, because it's just this current coordinate RC. So this recursion will just keep on going on. You will just loop through all of the possible positions, and finally you will return the maximum possible result. But here we also have to check whether we start going to the right or we start going down. So we also get the maximum of that and just print this out.